A financial institution deploys an artificial intelligence model to detect fraudulent transfers, but a security professional notices it sometimes flags valid user transactions as fraudulent. What is the most appropriate course of action? Option A, retraining the model using a broader dataset and updated transaction trends. Option B, applying API rate limits and token tracking for the AI system. Option C, encrypting all inputs and restricting access permissions for the AI pipeline. Option D, disabling the model and reverting to legacy rule-based detection methods. Okay, let's look at this question. The business goal is to detect fraudulent transfers, but the security professional notices it sometimes flags valid user transactions as fraudulent. What is the best appropriate course of action? Well, option A makes sense. If we have sufficient data for both fraudulent and valid transactions, retraining the model could potentially improve its accuracy. And by incorporating updated trends, we can be more responsive to changing patterns. So option A is a good first option. Now, option B doesn't make sense. Imposing rate limits on APIs is more of a security measure for protecting the AI system itself and doesn't directly address false positives. Option C is also not the right approach. Encrypting all inputs and restricting access permissions does not solve the false positive issue and only affects the confidentiality of the AI pipeline. And option D does not fit the situation. Reverting to legacy rule-based detection methods is not the optimal approach in this case, as the AI system has been deployed for a reason. So in this situation, option A is the most appropriate choice.
Let us think about what this question is asking. We're dealing with an artificial intelligence model used for fraud detection in a financial context. The core issue is that the model is generating false positives, meaning it incorrectly identifies legitimate user transactions as fraudulent. The challenge is to determine the best strategy to fix this classification error without unnecessarily discarding the system or applying unrelated security controls.
When looking at the options, I believe the correct answer is option A. When an AI-based system produces false positives by blocking legitimate transactions, retraining the model with a richer dataset is the most effective approach. By incorporating recent and diverse transaction patterns, we can significantly improve classification accuracy and reduce these operational errors.
Now, let us review why the other options are incorrect. Option B focuses on applying API rate limits and token tracking, which addresses API consumption and resource exhaustion rather than model accuracy. Option C involves encrypting inputs and restricting access controls, which relates to data security and privacy, but does not impact false positive rates. Finally, option D suggests rolling back the model entirely, which is an overreaction that discards the benefits of advanced machine learning detection when retraining is a standard remedy.